Oh dear, looks like I'm running out of fresh water. I'm gonna have to start boiling rainwater to make sure it's safe to drink. And what's the best way of doing that? I need about 5 litres per day. But I've only got 3 gas canisters left to supply the flame to heat the water. I'll have to find a way of making the most of them. Oh, I'll have to wait till later. Need it on the science line. How can I help?
Stella, we've been wondering, how do people design experiments? I mean, how do they know what to measure in a test?
Yeah, doesn't it get a bit confusing trying to test 3 or 4 things at the same time? How do you know one thing isn't affecting the other?
Well, perhaps they just guess how things are happening and get lucky.
They can't do that. Things would never get tested properly.
Stella, what do you think?
Bit of a brain tickler, this one. See what I can find out. Experiments can be good fun, and they can show you how different things affect each other. But what happens when you're trying to test something and you have to think up what experiments to do in the first place? It can all be a little confusing. Now, I've got to start boiling rainwater, and I need to know the most efficient way of doing it. So I've got all these things here, different size pots, pots made of different materials, some with lids, some without. Now, any one of these things could make a difference. So, which pot do I use to boil the water in? My supply of gas to heat the water is limited, so I need to make the right choice. And it could take me days to find out. Time I haven't got. I think I need Howie's help to see what's the best way to get a result.
At last, an investigation I can really enjoy. Stella's asked me to find out which of these two bikes is the fastest. Now, all I need is another cyclist, preferably a champion.
What a stroke of luck! There's Maxine Johnson, the champion cyclist.
Sounds too good to be true. Can't help having a bad feeling about this. Did you hear something? So, Maxine, what we need to do is race these 2 bikes against each other. This is a racetrack, so whenever you're ready, go!
Hang on, this isn't a fair experiment.
Yeah, he started before her, and he's a man and she's a woman.
What's that supposed to mean? They could be as good as each other.
Oh no, now Howie's gone onto the grass, that's going to slow him down. And that isn't fair either.
OK, that's the experiment finished, and your bike is definitely the fastest.
It's just not a fair result. There's just too many variables.
What do you mean?
Well, for starters, we're at different weights, different builds, different levels of fitness. In order to make it a fair result, we really ought to eliminate as many variables as possible.
So that instead of comparing everything at once, we're just comparing the performance of the 2 bikes.
That's right.
Come on, then.
If they're going to try and make everything the same for the test, they should maybe use twins. Twins are the same.
They might look the same, but even if they are identical, one might be fitter than the other.
OK, I've been thinking about these variables, and I reckon what we need to do is have one single rider going around the same course on each bike. And because you're the professional, I think it should be you.
Right, I'll try and go as fast as I possibly can. I'll actually keep on the circuit and I won't go onto the grass.
And I'll time you each time.
Now this is looking better.
OK! Have a rest, I'll get the next bike ready. 3, 2, 1, go!
This still isn't a fair test.
Yeah, he's using different watches. The stopwatch would be more accurate than the wristwatch.
OK, Maxine, we've got a result. Bike A, the mountain bike, 1 minute 47.2 seconds for the lap. And bike B, that's that bike, you took 1 3/4 minutes. So that's the same.
How can that be accurate, though? Because you haven't used a stopwatch for both readings.
No. Should I have done?
Of course you should.
All right, let's do it again. OK, Maxine, ready? 3, 2, 1, go!
I think he's done it right now.
Yeah.
Right, Maxine, here it is. A result we can trust. We use the same rider, the same track, the same stopwatch. And Bike A, that's the mountain bike, did the circuit in 1 minute 46.4 seconds. Bike B, the racing bike, did the circuit in 1 minute 40.2 seconds. So the racing bike's faster.
Well, I have to admit, it is a lot fairer this time, the result.
And you know what? I reckon I'm not going to need this anymore.
So, if I'm going to find the best way of making drinking water, I need to know all the different things, the variables, that might affect the result. I'm going to need some help deciding what the variables are. You got any ideas?
Well, there are lots of different shapes and sizes of pots, so that could be a variable.
And they're made of different materials. That could affect the results.
How is she going to heat the water? That can make a difference.
And also, how much water is she going to put into each pot?
Stella, there's loads of variables.
Yes, now the best way is to test only one at a time. Otherwise we'll get confused and the results won't make any sense. So, first, I'm going to see which kind of pot is the best to boil water in. I've got 3 types: earthenware, Pyrex and metal. And this is aluminium. But if it's going to be a fair test, I need them all to be the same size. So, I've got 3 exactly the same size, and I'm going to put exactly the same amount of water in each. It doesn't matter what the volume is, as long as there is exactly the same water in each. And then finally, I'm going to put a thermometer in each, so I can measure when the water reaches boiling point, 100 degrees Celsius. Now, I'll time it from when I start to heat them, and then I'll stop it when the thermometers have reached 100 degrees. And that gives me time to draw up a chart.
Hey, look at those flames. They aren't the same. Won't that make a difference?
Yeah, the yellow flame won't heat as fast as the blue ones.
That means the test won't be fair. Stella?
Yes, one of the flames isn't burning the same as the others. Now, that's better. It's got to be fair. Here we are, the final figures. Now, let's see. The earthenware pot took 18 minutes to boil the water. The Pyrex, however, was faster at 17 minutes. But even faster than that was the aluminium at 14 minutes. Now, because everything else in the experiment was the same, I know I'm getting a true comparison. So, of the ones I tested, aluminium is the best. Now that can remain a constant, and I can check if there are any other ways to improve things. And that's what Howie's getting into.
Excuse me. These pants are a scientific marvel. Why? Well, because they're the same colour as these pants. They're the same size and shape as these pants, and they're going to last as long as these pants. Impressed? Well, you should be, because whereas these were made here in Great Britain, these are from factories all over the world. What I want to investigate is just how the manufacturers know that all these are identical.
So I've come to see Catherine McCann, who's in charge of pants for a company that makes all sorts of clothes for one of Britain's biggest retailers.
Why is it so important that they're all the same?
Well, absolutely important. Imagine going into a store and buying a size medium one week and them not being the same size as the size medium that you bought last week. As you can imagine, there's a lot of variables involved in making a pair of pants, and we have to concentrate on those variables, right from the design stage to the choice of raw materials that go into making the pants and the actual way that we stitch the garment.
So the material effects and the stitching effects, then you've got all these variables catalogued. How do you actually go about making sure that they're not affecting the product?
Well, it's all about testing.
And they test a lot. As part of my quality pant investigation, I've got to make sure the weight of this material is exactly as specified by the company's rule book. In fact, every day, the company's labs do hundreds of tests on the material as it comes into the factory and on the pants before they leave.
So So by using the same rules for all the tests in all the factories, you can compare like with like.
Absolutely, but that's only half the story. We have to conduct the tests in exactly the same way.
And that includes using exactly the same equipment, even the washing machines.
This is a really special washing machine. It's driven by computer so that we heat the water to exactly the same temperature every time. The cycle time is absolutely spot on. We even have to use the same brand of washing powder and the same amount of washing powder every time that we do our tests.
Of course, if you didn't, those would all be extra variables, wouldn't they?
Absolutely. It's important that we standardise our testing so that we can compare the results, say, from this washing machine at Bolsover with similar results, say, from the lab in Sri Lanka.
So that means if something goes wrong with this wash, it's nothing to do with the machine. We know for a fact it's got to be due to defective clothing.
Exactly.
They even test to see that all the clothes look the right colour under a standardised light. The same light that's used in all the stores they supply. And if that wasn't enough, there's a rub test where you have to make sure the fabric will stand up to everyday use. And my tests show that the material matches the strict specifications in the book. So nothing wrong with my pants.
Oof, I'm tested out. But at least I see it is important to standardise your tests, because I now know that all my results can be compared to all your other factories.
That's right.
What's this? Piece of old junk?
Howie, it certainly is not. This is a twin tub, and this gives your washing the most vicious of washes. If your pants survive this, they can survive anything. You will find one of these in every single one of our laboratories. So, if you don't mind...
Oh, wait, what's this, more standardised testing?
No, I just need some help with washing.
I've decided which is the best pot, but I've been wondering whether this pot with a hole in its lid will make a difference. So, how am I going to test this? Same amount of water in each pot. Heat it on the same flame. See which one boils in the shortest time. Easy. Now, the container with the lid boils 2 minutes before the one without. That must be because the one without the lid is losing heat at the top. It may be the best, but it doesn't hold the 5 litres of water I need every day, so I better see if I've got any more. I hope Howie's spotting all the different variables, because his next investigation looks dangerous.
This is a great game. And the best thing about it is, if you get bored of the people you're playing with, you can remove one of the bottom supporting bricks, and there you are. Game over. Now, Stella's asked me to investigate something very similar, only she's given me a slightly larger pile of bricks. I've got to find out how the demolition crew are going to knock down this building without hurting anyone and without breaking next door's windows. Surely they can't just guess. So, Charles, what are you doing here?
Well, we've been asked by Hackney Council to demolish this 22-storey building.
So you're just going to blow it up?
Oh, it's a bit more complicated than that. If you just look around you, there's other apartment blocks, busy roads, there's services under the ground, electricity, water. So we've quite a bit to do before we get to blowing it up.
So you've got a lot of variables here, haven't you?
Oh, yeah. We've got to make sure that the concrete's the right strength and that the reinforcement's in the right place, and obviously that we've got the right explosives and the right charge weights.
Now, Charles can't obviously blow up the whole building just to see if their estimates are right. So what they do is carry out lots of small-scale experiments. They can then take their results and use them to work out what is likely to happen to the whole building.
OK, Howie, this is a section of wall where we've carried out a test already. We drilled holes in it and put some explosives in based on knowledge we'd got from other buildings. And as you can see, it's been quite satisfactory. The wall's disappeared. The object of the exercise was either to see whether the wall was taken out cleanly. If it wasn't, we'd need to put more explosives in. If it was taken out too cleanly and there was stuff thrown all over the place, we'd have to reduce the explosives. And from the test blast, we've been able to calculate how much explosive we need, where to put it, what the distance apart the holes are. All that's been put in the database now, so that on future jobs we can guess a bit more accurately. And as time goes on, all that information will make sure that the job is safer and more cost-effective.
So using test experiments to make the best of the variables, Charles will now use explosives in the same way that I play my game. By taking out the supporting blocks in the right order, he knows exactly where the building is going to fall. Will it work?
I hope so. I'll be looking to you for a job if it doesn't.
I asked if I could press the button, but Charles said that was one variable he was definitely going to do without.
I haven't been able to find any more metal pots, but I have found another lid with an even smaller hole, and I wonder if this will make any difference. Only one way to find out. The variable this time is the size of the hole in the lids, and I have a suspicion that the smaller hole will make the water boil faster because there's less vapour escaping. So I'm going to put a thermometer in each, but I'm going to take temperature readings at 1 minute intervals because I want to plot a graph to see how the two compare. Here goes. Start heating both at the same time and start the stopwatch. Now, to turn these results into a graph, I'm going to put time in minutes along the bottom axis, the x-axis, and the temperature in degrees Celsius up the side, the y-axis. Both beakers of water started the test at 20 degrees, so I can start the temperature scale at 20 degrees instead of 0. After 1 minute, the one with the small hole had a temperature of 28 degrees Celsius, and the one with the bigger hole, 24 degrees Celsius. So I'll continue to plot the results at 1 minute intervals. The graph shows the beaker with the small hole has a steeper line than the one with the bigger hole. That means it was faster heating the water. So, from all the experiments I've done, I can tell that these are the most efficient conditions to boil my water in. Now here's one for you. I've made this to collect the rainwater, but the material doesn't work very well. It lets the water through everywhere, and I just wanted to go through the hole into the bucket. So, what's the best material to collect the rainwater in? What was that?
We need to decide what the variables are.
So what sort of material are we looking for?
Well, waterproof. We only want the water to come out of the hole in the centre.
And what about the size? Surely if it's bigger, it'll catch more rain.
And it needs to be strong, so when it's wet, it can't fall apart.
Well, that's enough variables for now. We need to find out...
Hang on, there's that noise again.